In this video, we will learn how to use an LM35. This is a temperature sensor. Okay, so we will build a temperature monitoring system that helps us to measure the temperature in our room or in our environment. So for that, what we need, the component required here of course, a sensor, an LM35, which is a temperature sensor, an LCD screen with an adapter, I2C, an Arduino, a breadboard, an RGB LED, some resistors, and of course, jumper wires. Okay, so very good. Uh, so we're gonna first of all we're gonna build our circuit. To do that, look here. Can you see my circuit on the ticket car software? So we need to put the LM35 in the on the breadboard. So let's go put it on the breadboard. Okay. Very good. Can you see? This is I put it on the breadboard. Then the next thing to do connect uh is to connect the pins of the temperature sensor. So both um the Arduino and maybe the LCD. Okay. So this pin is the VCC. This is the favor. The middle pin is the V out, which is connected to the analog pin A0, and the final pin, the right left is connected to the GND. This is the ground. Okay, let's go for that. So this is the VCC. This is this pin is V0, the V or V output, and the final one it is of course the GND. Okay, can you see it? Let me show you more closely. Very good. So this is connected to the GND. This is connected to analog pin A0 of the Arduino. Uh, Here you have. Okay. So let me show you more closely. So this is the this is connected to 5 volt. This is the analog pin A0. Can you see it on the ticking card? Okay, very good. So and the final the white leg is connected to the GND. This is the ground. Okay, we do the same things here, and let's continue with our circuit. Okay, perfect. Okay, can you see? Let me show you more close. Very good. So the next thing is to add the the RGB LED on the breadboard. So let's go for that. This is the RGB LED. I will put it on the circuit. Can you see it? Can you see it? Very good. Now I'm at the resistor. This is okay. And then this is another leg. So we skip this leg, this middle leg, because it is connected to the JD. Can you see it? This leg. I will show you more closely. This leg, this one is connected to the GND. So we skip this and let's start with this. Okay, this is obviously, can you see it? Very good. And then this is this LED is connected to this is let's say this LED. Can you see it more closely? Very good. So on the ticket card, we first put this resistor, and then this one, and finally this resistor. So the first resistor, it is the red of the LED. So let's put red. Choose a red jumper wire. Put it here, and then this leg, it is the red it is connected to the red. It is the red. Sorry, it is the red pin. So this is let's say mm, let me rearrange the circuit. This is the red pin, and finally for the LED, this is the blue pin. Okay, this is the blue pin. Can you see it? And then so the red pin is connected to digital pin uh number 9. This is obviously this is connected to digital pin number 9. And the green pin is connected to the green pin here is connected to digital pin number 10. Where is the green pin? It is connected to digital pin let's say number 10. And finally the blue pin, this one is connected to digital pin number 11. Okay, perfect. Okay, so I think that's all for the RGB LED. Now let's move on and take care of the let's move on and take care of the LCD screen. So this is our LCD. This is we have the GND. We have the we have subvert here. This is the STA, the blue one. Sorry, the white one, it is the STA, sorry, and the last one, it is the SCL, sorry. Okay, so here you have. Let me show more closely. Can you see it? Perfect. So first of all, we need to connect the GND to the breadboard. So let's do that. This is the GND, and then the favor. Okay, and this pin. So we have connected the GND and the fan board, and now let's move on for the analog pin A4. Analog pin A4. This is the white color, the white jumper wire. It is connected to analog pin A4, and finally the SCL is connected to analog pin A, or let's say A5. Do that. Okay, perfect. Can you see it? Now I think there are two important things that remain. So we need to connect the GND of the Arduino to the GND of the breadboard. So let's do that. This is the GND of the Arduino is connected to the GND of the breadboard, and then the 5 volt, the last jumper wire, the 5 volt is connected to the 5 volt of the LED, of the breadboard. Okay, so this is the 5 volt of the Arduino. Let me show you closely. This is 5 volt of the Arduino. It is connected to 5 volt of the, okay. Let's change this jumper white because it will not work because it is damaged. So I will choose another color. Okay, there you go. So this is the GND. This is the 5 volt of the Arduino. It is connected to the 5 volt of the breadboard. Very good. So now the second is ready. We can copy the code. Let's copy it. Don't worry, I will explain you every single line or detail of the code. So we need to copy it. I will also put the code on the comment sections or on the description of the video. We have copied the code and then pass it. Okay, but let's verify it. So perfect, perfect. It works. Now we need to set up. We need to set up. We need to plug. So we need to plug our Arduino. So let's plug it. Very good. Now that the Arduino is plugged, let's upload the code. Perfect. Very good. So can you see sorry, we need to we need to we have forgot some pins, which is the digital pin of the RGB LED. So we need to connect the digital pin, the GNT pin, sorry, the GNT pin of the LED. We need to connect it to the GNT of the breadboard. That's why the LED is not working very well. So let's unplug the Arduino, and then let me show you again the ticket card circuit. Okay, can you see? So we need to connect this pin. Let's say, okay, this is the GNT or the RGB LED. It is connected to the GNT. Ah, can you see? Okay, very good. So we need to plug again the Arduino, and let's move on the second of the code. Okay, let's upload the code again and see what will happen. Very good. Very, very good. Let me show you more closely. Let's say, uh, so let me show you more closely. Can you read the value on the LCD screen? Uh, Currently the temperature is 70 20 26 or 27, let's say 27 dot 9 degrees Celsius, and the status is normal. So when the temperature is below 30 degrees Celsius, then we say it is normal. But when we are above 30 degrees Celsius, then it is too hot. And when it's too hot, naturally the LED should be red. But currently it is less than 30 degrees, then it is normal, and the RGB LED is currently red, is currently green. That means that it is normal, and the temperature it is not above 30 degrees Celsius. If we bypass, or if we surpass the 30 degrees Celsius, we see that the temperature of the RGB LED color will change. We go from red, or sorry, we go from green to red. Okay, so that's all, and you can see the LCD here. Very good. So don't worry, I will explain you every detail of the code, and the code will be put on the comment section or on the or in the description of the video. Okay, very good. So I think that's all, and let me explain you the code. Perfect. So let me explain you the code. Okay, very good. The first line here, on the first line, we include, let's say, we include um, the wire, um, the wire library. Okay, we include the wire library uh, to enable what? To enable the I2C communication. On the second line, what we do here is that we include the library. We include the liquid um, crystal I2C library for controlling uh, the, the LCD via the I2C. Okay. Uh, in this line, okay, what we do is that we create, first of all, at first we create an LCD object, and then the second stage is to be the address. So this is we create the LCD object, and then we need to include the parameters on the LCD screen. So this first parameters is the address. This is the address of the LCD, and then um, uh, 16 is the numbers of columns here, and 2 is the number of rows. Okay, very good. Next, we do what? We need to declare the LM35 pin. So this is LM, let's say 35 temperature sensor. Uh, is connected um, it's connected to analog, let's say analog pin A0. And then let's move on the RGB LED the RGB pin assignment. So the RGB LED pin assignment. Okay. So very good. So this is the green LED the green uh, the green the green LED pin is connected to digital pin number 10 of the Arduino. Okay, and we do the same things here. Okay, so so this is the red pin. Sorry, so the red pin, the red uh, the red LED pin is connected to digital pin number 9 of the Arduino, and the green LED pin is connected to digital pin number 10 of the Arduino, and the last one is that the blue LED pin is connected to G pin 11 of the Arduino. And now we need to explain the setup functions. So the setup function is not it is easy to understand. Okay. What we can say about the setup function is that uh, the setup function is not difficult to understand. So uh, the setup the setup of a function uh, once only once once when the Arduino starts. Okay. And the purpose of this the purpose of this function is that first we initialize let's say LCD, and then uh, we configure the LED pins as an output or as outputs, and finally we start uh, the serial communication. Okay. So here what we do is that we uh, we initialize we initialize uh, the LCD, and the second line here is to turn on the LCD, let's say backlight, and now we need to configure the RGB. We need to configure the RGB. Configure RGB. Let's say LED pins as output. So this is the red pin output. This is the red pin output, and the last one is the blue pin output. Okay. Now we need to start uh, the serial communication at 900 board with it is useful for debugging. Okay, it is very useful for debugging and monitoring um, to monitor values. Okay, we don't need here to we can remove this. Perfect, very good. Okay. The next things to do is to explain the void function. So the loop function, it is very easy to understand. Also, like the setup function. So let's say that this is the loop function. The loop function. It runs repeatedly. It runs repeatedly forever when the power or when the Arduino is set up. Okay, the purpose of this function is that let me change the language of my okay. So the purpose of the loop function is that we wait with that function the LM35 sensor value. Okay, and then we convert okay that waiting value into temperature, and then we display this temperature value on the LCD screen, as you can see here. And finally, we change the LED color based on uh, the temperature. This is red. Let's say okay, and what are those color? It is red if the value of the temperatures is less than if temp value is less than sorry it is let's say blue. If temp value is less than let's say 25, uh, it is red, which is the normal. And the meaning is that it is cold, and then here it is red if the temp value is less is is more than 25, and less than 30. So what is the meaning here? It is hot. It is normal. Sorry, it is normal. And finally, uh, so this is green. Okay, this is green. And finally, it is red. The RGB is red. The RGB LED is red when if the temperature value is less than let's say is more than 30. If the temperature value is more than 13, then what is the meaning? It is hot. Okay, very good. Now let's explain every line of a loop function. So the first lines are we need to, let's say, we read the analog value from from the LM35, let's say the LM35 sensor. This is this pin here. Can you see it? This pin. Okay. This pin, the middle pin. This is the V output. It is connected to analog pin A0. Okay. Uh, and this value on it range from it range from 0 to, let's say, it range from 0 to 1033. Okay, and then the next thing that we do is uh, to convert analog rated voltage of the Arduino to we convert the analog value with from the LM35 sensor to the digital value, as the Arduino only recognize digital value. Okay, right. And this is what happened here. What you're gonna say is that okay, we convert uh, analog rating to voltage, and uh, with Arduino use the analog to digital conversion, which is the weight value 0 means that 0 means that we have 0 volts here, and then 1000, let's say 1023 is means that we have 5 volts here. Very good. And the formula beyond these conversions is that okay, let's say voltage equal to the ADC. This is means analog to digital conversion reading multiplied by the reference voltage divided by 1033. Okay, and then we need to convert the voltage to temperature here. So we need to convert voltage to temperature. Okay, okay, and then we move the cursor to first column of first row. We display let's say we display or print print the word we print the word temp on the LCD. And finally what we do here is that we display temperature with one decimal place, and we display here, let's say we display the degree symbol. This is the degree symbol with the ASCII conversion. Okay, and we display the Celsius here. Display Celsius units. And after that, we need to move the cursor to first column of second row. Okay, now we need to take some decision according to the value or based on the value of the temperature. So let's say let me copy this. %. This is the temperature decision making. Okay, if temperature is below, let's say 25 uh, degrees Celsius, what what will happen is that uh, we set the RGB color to blue. So set sorry RGB LED to blue. Okay, and if temperature is between 25, let's say 25 degrees Celsius and 29.9 degrees Celsius, then we set we set RGB RGB LED to green. Okay, and finally if temperature is more than 30 degrees Celsius or more higher, then we set up we set RGB LED to red. This means that it is too hot or it is hot. So here, okay, very good. Now the last functions here is that and here don't forget that we wait 1 minute or 1 second before taking another waiting value or another value. And then we need to this is the setup color function. The purpose is to control the RGB LED color by changing the brightness of the LED, of the red, green, green, and blue LED using PWM. The parameters here are R, J, and B. The R brightness of the red range from 0 to 255. The J brightness of green LED is 0 from 255, etc., etc. Okay, very good. So here we need to set bright the brightness of red LED. Okay, set the brightness um, of the green LED, and finally we need to set the brightness of blue LED. Okay, so that's all for this for the code. I hope that you understand everything you learn in the code so that you can do the same things. Okay, don't forget to use AI like ChatGPT, Claude, Grok, etc., etc., to help yourself to understand so this those line of code. Okay, so thank you very much and see you for the next time.